Okay, before we begin, can I just please get confirmation that you guys can see me as well as hear me, as well as see my screen? Maybe I need to okay, there we go. You guys should be able to type now. As well as on YouTube, if you guys can please confirm that you guys can see me. Okay, perfect. Cool. The screen is blurring. Okay, let's try resharing. 1 second. Okay, it should be a bit better now. You can just confirm for me if it's better. Okay, perfect. Okay, let's continue. Okay, Assalamu alaikum and good morning. Welcome back, guys, to grade 12 mathematics by Inspired Teens. Where in today's lesson, we're going to continue with functions. We're taking a really long time with functions. We're going to really try and sort of pick up the pace because we still need to get through trigonometry, which is still a term one topic. Okay, so yeah, that being said, let us start. If it's still blurry on the YouTube end. Blurry again. Hmm. Okay, just give me a few minutes. I'm going to try and fix it. Hello, can you guys hear me now? Okay, sorry about that. Okay, so I was saying that last week we discussed interval notations, right? So the first thing we discussed was include and exclude. Okay, we discussed the circle bracket and the round bracket. Circle bracket represents exclude, so a square bracket represents include. Okay, we said include represents what? If I'm not mistaken, we did an example with numbers somewhere at some point to say what it means. Okay, include is just basically you're going to include the number that's on that side of the interval, and exclude means you won't include it, right? And then things we never include, negative and positive infinity, as well as asymptotes. When we're dealing with asymptotes, when we deal with positive and negative infinity, we don't include those things. Okay, so let's have a look here what we discussed. So firstly, we discussed a simple concept to where we determined the values, the x values, okay, for which x is greater than 0. So first we need to understand what is x being greater than 0, or where in the Cartesian plane will you find x values greater than 0. So you will find x values greater than 0 to the right of the y-axis. Okay, to the right of the y-axis is where you will find x values greater than 0, and then we identified that part on the graph, so we highlighted it. Okay, then all we need to do is express the highlighted part, okay, in terms of x values. Okay, so remember x values work according to the x-axis, so we have to match it to a corresponding value along this line, anywhere along this line, wherever our interval is. So of course we always work from left to right. So the starting point for us on this highlighted part of the graph, okay, is here. Okay, this is not -3. Remember we said we're looking at x values. Okay, that's actually x is equal to 0 at that point. Okay, just be careful. And then we can see that this is going to be highlighted forever, right? This graph is going on forever up and forever to the right. So in that case, we know that it's going to go to positive infinity. So we represented our interval as x is an element of our start value and our end value. Our start value is 0 and our end value is infinity. Now, the reason we didn't include infinity is because we never include infinity. The reason we didn't include 0 was because the question didn't include 0. So when the question doesn't include like that, then we don't include as well. And then these things here, no matter what the question says, we exclude them. Okay, then we discussed this one where we said x is less than or equal to 0. So we need to give the x values for which x is less than or equal to 0. And we said that, how do we understand, so x less than 0 is obviously negative x values. How do we understand negative x values in terms of the Cartesian plane? We understand that it's to the left of the y-axis. So then we go to the graph and we highlight the part of the graph that is on the left-hand side of the y-axis. And that's exactly what we did. We highlight the part of the graph for which this is true. X is less than or equal to 0 for this part of the graph, because it's to the left of the y-axis. So we highlight it, and then we now express it in terms of x values. Okay, so just, yeah, okay. So we're going to do it in terms of interval. Again, this is it's like the same thing, and it's really easy, but to get the understanding down, it's important for us to understand it, right? So yes, now we work from left to right, and we have to express this highlighted part of the graph in terms of x values. So again, we work with the most left value of this highlighted part of the graph. You can see that this graph is going forever up and forever left. Okay, so the most left value is actually going to be negative infinity, and that's why we said x is an element of negative infinity. And the most right value is here. Okay, remember it's not -3. Here it's x is -3 is the y value. We are focused on the x value. X is equal to 0 at that point. So it ends at 0 essentially. Okay, so x is an element from negative infinity up until 0. And why do we include 0 this time with a square bracket? We include 0 this time with a square bracket because the question includes as well. Since the question includes, we include. Okay, then of course this interval this is the inequality notation, would be expressed as the question is given. Okay, x is less than or equal to 0. Then we discuss this for which values, determine for which x values f of x is greater than 0. Remember, we said that f of x being greater than 0 means y is greater than 0. Y being greater than 0 means that it is above the x-axis. F of x being greater than 0, that means the y value is greater than 0 because f of x is y. Where is y greater than 0? Above the x-axis. So that's why we highlighted those parts of the graph, because those are the parts of the graph which are above the x-axis. And then those highlighted parts, we have to express it in terms of x values. So again, you start from your most left value and your most right value. So we go to the highlighted part. Like I said, you can even draw dots, right? A dotted line to say, okay, this is my start point, this is my end point. At this dotted line, I need to find the x value. Okay, so again, we can see that this graph is going forever left. So its starting value for this interval is negative infinity. Where does it end? It ends here, just before it goes below the x-axis. That's where our point is going to end, because that's the part that's above, which is true for this. Okay, so where does it end? Remember, x value, we always answer in terms of x values. So we start at negative infinity and we end at negative 2. And that's why our answer here was x is an element of negative infinity all the way to negative 2. Why didn't we include the negative 2? Okay, I understand infinity we never include, but why didn't we include the negative 2? Because in this case, the question didn't include, so we won't include. Let's look at the next one. So here there's two answers because there's two parts of the graph. So we have to answer this highlighted part, or we have to express this highlighted part, this one here, in terms of x values. Okay. And we again, x is an element of the most left value and the most right value. We can see that the most left value is here, where the value for x is 1. And the most right value is forever up, or forever right, actually. That's positive infinity. So we start at 1 and go all the way to positive infinity. Let's look at less than. F of x is less than or equal to. So this time we probably gonna need to include. F of x being less than or equal to 0 means y is less than or equal to 0. Y less than or equal to 0 means below the x-axis. Okay, so in this case, as you can see, I need to identify the part of the graph that's below the x-axis, and that's what I've done. I've highlighted the part of the graph that is below the x-axis, and I now need to express this in terms of x. So I need to express the highlighted part of the graph in terms of x. And again, remember, x is an element of include or exclude, whichever, your most left value and your most right value. Your most left value and your most right value. So in this case, x value, most left x and most right x. So in this case, my most left x value is negative 2. My most right x value is 1 as given. And we answer x is an element from negative 2 to 1. Yeah, both included. Why do we include both? Because we are not dealing with infinity. So there's no reason to exclude for infinity here. We're not dealing with an asymptote. By the way, this dotted line is not an asymptote. It's just my own construction that helps to identify the interval, okay, to answer the interval. So just keep that in mind. It's not an asymptote, right? So then we have, okay, then we have, yeah, I don't even know what I was saying, but basically, yes, negative 2 to 1, both included. Cool, let's move on. Okay, so let's look at an example like this, right? Where it says determine for which x values f of x is greater than g of x. Determine for which x values f of x is greater than g of x. Okay, so yes, now in this case, give me 1 minute, I'll just share my screen in a second, and then we can continue. Load shedding throws everything off. Okay. Share my screen in a second and then we can continue. Okay, I trust that you guys can see my screen again. So we have, okay, f of x greater than or equal to g of x. Okay, so remember this or equal to, that's just gonna tell us we need to include, okay, for that given interval or whatever it is. Now, f of x being greater than g of x is like a y value being greater than or equal to another y value. Okay, now let's look at our y-axis and ask ourselves, what does that actually mean? So if I have to look at a y value being greater than another y value, let's just call this y for f and y for g. Okay, if I have to again look at my axes, okay, and I have to understand, okay, how would it be, how would these 2 points be relative to each other if one is bigger than another? So that's easy, right? Here my y coordinate may be 1. Here my y coordinate may be 2, 3, maybe here's -1 and so on. But if we have to compare like 1 and 3, 3 is clearly bigger than 1, okay? And we can see that 3 is above 1. That just makes sense, right? When one y value is greater than another, it's above that other one, okay? Because that works with the y-axis. So like 1 and 2. 2 is greater than 1, 2 is above 1, okay? So that's exactly how it works with the graphs. When they are asking for x values for which f of x is greater than or equal to g of x, yes, they are essentially saying, give us the x values for which the y values of f are above the y values for g. Okay, in that case, it basically means f of x above g of x. Okay, that's a bit more English, so that might make more sense to you, right? Because that's what this represents. F of x being greater than or equal to g of x means that they're asking for the x values of this graph that's given, for which the y values of f, because that's why they say f of x, are greater than the y values for g, because that's why they say g of x. Okay, remember, f of x, g of x, these represent y. Okay, and basically what it essentially means is that they're asking for the values, if we have to describe it in English, okay, or diagrammatically, they want the x values for which f of x is above g of x. So that's what we have to identify. So the way we actually compare it, what we need to look out for is the fact that this here it changes at the intersection points. Okay, so basically what that means and what I'm trying to say is that, okay, f of x is above g of x, then when they intersect again, then g of x is going to become above f of x. When they intersect again, however many times they intersect for the given interval, okay, they will swap. Okay, and let's have a look at it, right? So remember, here are my intersection points, right here and there. These two coordinates, -3, -1, 2, and -2. Those are the points of intersection of these two graphs. So let's see how what I just said is true, diagrammatically speaking, okay? So let us, what you can do is, because I'll tell you why, to understand it better, I'm going to draw a dotted line. When you're answering the question, if you find the dotted line helpful, you may do it as well. This is not an asymptote. This is just construction line to help us answer the question. They're not that straight. Let's try and make this slightly straighter. Okay, so now we have the two intersection points, and you'll see that actually when you do this with the dotted lines, you've separated the given interval for these functions or these graphs into 3. Okay, you separate it into three different like portions. Okay, one is before the first intersection, the second is between the two intersections, and the third is after the second intersection. So when we look before the intersection point, before the first intersection, and we consider that's a bit too big, eh? And we consider f of x, so, and we consider f of x, okay, and we consider g of x. Okay, which one is above in this interval? Which one is above the other? Is f of x above or is g of x above? What do you guys think? F of x, good. Can you guys see my camera? Okay, I think you guys can. Okay, f of x. Good, right? So it's easy to identify it visually. Okay, that's really good. Then when we have a look at number 2, which one is above? Okay, so I'm going to change this to green and red for the sake of above and below. So this one is below at this interval. This one is above. Okay. Sometimes does it stop working? Okay. G of x, right? So correct. In the second interval, we can clearly see that g of x is above, and then this guy is now below. Okay. And then what about in interval number 3? Which one is above? And which one is above in interval number 3? F of x, right? Very good. Okay, so f of x is above. So you see, when you break it down, when you sit like, okay, this question wants me to find out when f of x is greater than g of x, you sit there, you draw your dotted lines in pencil, right, neatly, and then you understand, you look at it, you separate into 3 segments, and then you say, okay, in each segment, which one is above each time. So basically, oh wait, yeah, okay, we've identified, okay, the parts of the graph, and we've identified which one is above. Okay, so we know in number 1, f of x is above, number 2, g of x is above, and number 3, f of x is above again. So basically, diagrammatically speaking, we've solved the question, right? We understand, we've highlighted the parts of the graph that are above, okay? And this is the best way to do it, the simplest, the most broken down way that to do it, right? Separate into its 3 segments and decide. It's much easier to see, right? Remember, when we're talking about which one is above, yes, visually it's above, but we can see that its y values are also way bigger. Like this could be positive 5, but this red function g of x doesn't even go greater than 1. Sorry, greater than 0, right? So clearly f of x is above. So the question wanted us to find values for which f of x is above g of x. So in which sections, 1, 2, or 3, which section or sections is f of x above g of x? Which sections or section 1, 2, or 3 is f of x above g of x? Okay, section 1 and section 3. So let's get rid of that because I'm not really focused on that. All right, let's get rid of that because I'm not really focused on that. I'm just focused like, okay, those are my parts of the graph those are the parts of f of x which are above g of x. Okay, the highlighted regions, okay, are above g of x. Done. Okay, now you see, I feel like most of you get to this step and then you fumble when it comes to answering. So again, follow the same procedure. Like how we did the simple questions, we do these complicated questions as well. We look at both highlighted regions of the graph and we ask ourselves, what are the x values? Okay, so you're going to say x is an element of, okay, then you're going to look at this highlighted portion of the graph and you're going to say, what's my most left value? What's my most right value? Okay, so I'll do the first one, you guys can do the second one. So X is an element of, for this one here, the most negative value, the most left value, this thing is going till infinity. So its most left value is negative infinity, and I don't include because I never include infinity, right? That's its most left value, negative infinity. What does it go up until? Oh, it stops at this red line. That makes sense because remember we said at every intersection point, they flip. Okay, so if f of x is above g of x in section 1, in section 2, g of x is going to be above f of x. Okay, so it stops at that red dotted line. That's why we draw it. That's why if you're getting confused, I'd recommend drawing it. Okay, draw that straight dotted vertical line so that you can clearly see, okay, I need to get this x value that's on this line. That's the x value I need to get. Not confuse it and put the y value, for example, like we did in the last lesson. Right? Don't confuse it with that y value here. Like it's easy to say, oh, that's y, that's -3. The x value is -3, but that's not the case. The y value there is -3, x is 0. Okay. Oops. Not good. Okay. So x is an element of negative infinity, and it ends at whatever the x value is there, and it's 3. Do I include or exclude? I actually have to include because the question includes. Okay, this is nothing to do with include, exclude, by the way. This is just representing coordinates. So yes, x is an element of negative infinity, which I never include, to -3, which I include because the question includes. Okay, now I want you guys to give me the answer for this one. So, okay, we can do it step by step. Let's just say x is an element of, x is an element of my most left value. Okay, so I want you guys, we'll take it step by step. Okay, then like when we do the next question, we can speed it up. X is an element of, okay. So firstly, give me, before I worry about this, which one it is, give me my most left value of this highlighted part of the graph. The most left value of section 3. Positive 2. Okay, are we sure it's not -2? Okay, positive 2 indeed. Positive 2 is the correct answer. Okay, so now tell me, do I include or exclude positive 2? Do I include or do I exclude positive 2? Include. Why do I include? Exactly, because it's included in the question. Okay, so since the question wants us to include, because this is basically saying this here has two conditions. It has one condition that says f of x greater than g of x, and it has a second condition that says f of x is equal to g of x. They want the x values for which f of x is greater than g of x and f of x is equal to g of x. That's what it means, because greater than or equal to. It's this or this. Okay, so that's why we include it, because at 2, if we look carefully, f of x is equal to g of x, because that is the intersection point at 2. So that's why we include, technically speaking. So in that case, we can now say include 2. What's my most right value? What is the most right value of my green highlighted part of the graph? Positive infinity. Very good. You don't have to put the positive sign when you're writing your answer. You just put infinity. Do I include or do I exclude for this one? Do I include or do I exclude for this one? Positive infinity, exclude, because you always exclude infinity. Correct. Okay, so I exclude. Okay, cool. All right, so that's our answers for that one. Okay, let's move on to the next. For this one, I'm going to try and do 2, and we'll take it from there. Okay. Okay, so I hope everyone understands that. Let's continue. Determine for which x values f of x times g of x is greater than 0. Determine for which x values f of x times g of x is greater than or equal to 0. Okay, so what does this mean? Firstly, because we are dealing with f of x and g of x, we are dealing with two y values. So exactly how it's stated, this is a multiplication of two graphs. So you're taking a y value, like a y value of f, so we can even say y of f times the y value of g, and it's greater than 0, greater than or equal to 0. So when do you get a positive in multiplication? Essentially, when you multiply a positive by another positive, that's when you get a positive. Okay, when you multiply a negative by a negative, that's also when you get a positive. Okay, any other combination is going to give you a negative. These are the two combinations where you get a positive. When you multiply a positive with a positive, you're going to get a positive. When you multiply a negative with a negative, you're going to get a negative. Okay, so now, how do we answer? What does that mean for the graph? When is f of x positive? It's exactly what we learned in the previous. So basically, when we're doing multiplications of graphs, in order to answer it, we need to understand, because it's greater than or equal to 0, we need to have firstly positive times a positive or a negative times a negative. So this needs to be positive. At the same time, this needs to be positive. When we multiply them, then it will be true that it will be greater than or equal to 0. Alternatively, if that's negative and that's negative, then it will also result in being greater than 0. Now, how is f of x positive? Like the previous question, not the previous one, the one just before that, remember? We did that when is f of x positive? F of x is greater than 0, which is positive, above x-axis. F of x is greater than 0 when we are above the x-axis. So f of x being greater than 0 and g of x being greater than 0 means g of x above the x-axis and f of x above the x-axis at the same time. F of x above the x-axis and g of x above the x-axis at the same time. So we can identify them one by one. F of x being above the x-axis is here, and g of x being above the x-axis is all the way there to positive infinity. Now, we need to identify the part of the graph where both of them are above the x-axis at the same time. So when you highlight it, okay, maybe it's easy to identify, easier, but there's still a few mistakes you must look out not to make, okay? So when we look at this, right, we can see that, firstly, someone tell me what is the most left value for f of x for this interval that I've drawn, for this highlighted part. What's the most left value for f of x for the highlighted region? -2, right? Correct. So for f of x, this is my most left value. Okay. Now, what's the most left value for g of x? This is, this is g of x. What's the most left value for g of x for its highlighted part, the odd red highlighted part? Okay, correct, -2 as well. So they share the same minimum values. Okay, so basically how you can understand that is they both, so prior to -2, they were both below the x-axis, and both of them after -2 came above the x-axis. Okay, they became above the x-axis. Okay, up until a certain point, however, what is the most right value for f of x being above the x-axis? What's the most right value for f of x being above the x-axis? 5, right? Very good. Now, what's the most left value for g of x being above the x-axis? What's the most left value for g of x being above the x-axis? Positive infinity, correct, because this thing goes forever up. See, I'm going to come back down and go below the x-axis again. It goes forever up. So we need to find the portion of the graph, okay, that satisfies not one, but both criteria, meaning f of x needs to be above and g of x needs to be above at the same time. Okay, so the second that g of x went below, we had to end it. So they start off at the same point. So our answer is going to start off at -2. That's obvious because like they both were above the x-axis at the same time, right? So they start value, their most left value is here, okay? And now they are both above, so both above, both above, both above, both above, both above, until this new dotted line. What is this dotted line? This dotted line shows where g of x actually went to the bottom. G of x intersects with the x-axis and it goes below the x-axis, okay? And at this point now, we can see that f of x is below the x-axis while simultaneously g of x is above. So we cannot, even though the thing I'm trying to point out here is, even though, okay, even though g of x starts at -2 and goes all the way to positive infinity, so that would be the answer for g of x. So I'm going to know g of x being above 0. However, we need to fulfill the criteria for both. We need to fulfill the criteria for f of x and g of x. So they both need to be above at the same time. That is the important thing. And if we consider after +5, we can clearly see that one is above while the other one is still below, or just came below. Okay, so essentially what you could do a long way is identify both their left points and right points, okay, and find the interval that is true for both of them. Okay, so yes, I hope that made sense. That was our first part of the answer done, not done, but highlighted, okay, to say that from -2 in terms of x values, all the way up until 5, okay, we have this interval that has both graphs, f of x and g of x, above the x-axis. Okay, as soon as we pass 5, g of x is above while f of x is below. As soon as we go before -2, both of them, excuse me, are below. So our answer for the first part is going to be yes, we can write here. X is an element of the most recent value and the most left value and the most right value. What's the most left value of this interval, people? What's the most left value? -2. So I put it in. Do I include or exclude? Okay, include correct because the question includes, so include -2. Now, what's the most right value for the interval where both graphs are above? What's the most right value? Basically, the last point at which both graphs are above. 5. Do I include or exclude 5? Include as well. Very good, very good, very good. Okay, just give me 1 second. Okay, cool. Perfect, very good. Right, so I hope this is making sense slowly but surely. We're going through it really slow. I feel like it requires that. But yeah, hope it's making sense slowly but surely. Okay, so that's one half of the question done. Why is it one half of the question done? So basically your answer is going to be of 2. You're going to have this as one of your answers and then the next answer also as well, right? So why is it one half of the answer? Because we've answered this. We've given the interval for which both are positive, meaning both are above the x-axis at the same time. We still have this criteria because you can get a positive number by multiplying 2 positives and by multiplying 2 negatives. So now our task is to identify the parts of the graph where f of x is below and g of x is below. So again, also, by the way, the longer you do it, the better you're going to get at it, right? The quicker you're going to be able to see. So if we have a look here, what you can always start off with is, get rid of these. Okay, you can always start by just identifying the parts of both graphs which are below. So let's look at g of x. The only part where it's below is there. F of x on the other end, however, is there, and f of x is there. Okay, so we need to identify the part of the graph where both are below. So let's look at, since we only have one purple to compare to, let's look at the orange, which is the parabola f of x graph, and it's below here and it's below here. Before -2, we have to look at where is g of x. Before -2, g of x is also below. So that fits our criteria actually, because both need to be below. Both need to be negative. That's how you get a negative. Okay, below. So excuse me, sorry. So in that case, since we've analyzed f of x is below here and g of x is also below for that given particular given interval, we can give our first answer now, right? X is an element of, what is the most left value of this interval? What is the most left value of this interval? Correct, negative infinity, right? For both of them are going to negative infinity. If one had to stop, we'd stop the interval along with it. Okay, what's the most right value? -2. Excellent, right? So I'm going to say x is an element of negative infinity. I don't ever include up until -2. Now -2 I include because the question includes. Okay, cool. So there are many other variations. So that's our final answer, by the way. Positive and positive, right? You just identifying the parts of the graph where both are positive, meaning both are above the x-axis, and identifying the part of the graph where both are below the x-axis, negative and negative. And okay, then so that's why I recommend, especially if you're struggling, okay, especially if you're struggling to see these and you look at these questions and you just want to cry, try out this approach. Okay, try out drawing on the diagram. Okay, showing on yourself on the diagram what is going on, right? Where are your intervals, right? What's above what, where? Okay, which way is what positive, where is what negative, and so on. And you can highlight it, right? Remember, in the exam, you're not going to get as many questions as we just did. You're going to get like 2 or 3 at most, right? Generally, like I would say, average 2, right? So yeah, so basically, lost my train of thought. Okay, doesn't matter, but anyway, yes, you can solve it using this. Dotted lines, okay, identifying those certain parts of the graph, for example, for intersection points. Okay, those intersection points are key because that's when things change over. and here identifying both positive and negative and negative. Okay, so before we go there, let's look at another example. Sorry, I'm not sure what you are saying, good son. If I have x over f of x, okay, let's just multiply first. What happens if you get this x times f of x? Give the x values for which x times f of x is greater than 0. So this is a lot more simpler than you think. X, okay, what does x mean? So again, we follow the concept where we have to have a positive and a positive and a negative and a negative, right? So positive x values, right? How do I know that a value is positive? How do I know that the x value is positive? Positive x values are to the right of y-axis. Positive x values are to the right of the y-axis. Okay. Negative x values are to the left of y-axis. Okay. F of x being positive, we just went through this. F of x being positive means above the x-axis. F of x being negative means below the x-axis. Okay. Then okay, so basically you need to solve the portion of the graph where f of x is x times f of x, where x is positive and f of x is positive. So x being positive means it's to the right of the y-axis, and y being positive means it's above x-axis, and y being negative means below x-axis. Okay, so essentially for this one, we'll be solving, okay, again, you have to do both, like meaning you have to do this. Oops, that's an eraser. You have to do this, and you have to do that. Okay, because both would satisfy this interval or this inequality, where both are positive and both are negative. Okay, so both being positive, again, like I said, one is x. Okay, so remember, you're always taking which x value, even if there's two graphs, you're always taking the values for x of f of x, okay, because it's they paired it together with f of x, always. Okay, you're not taking the x values of g of x, you're comparing the x values of f of x, and x values being positive means to the right of the y-axis. So like I said, you're looking for the portion of the graph that's to the right of the y-axis and above the x-axis. So you can identify the parts of the graph that are to the right give this a value. Okay, so what did we say? We're looking for the part of the graph that's to the right of the y-axis and below. So like I said, you can identify the entire part of the graph that's to the right. Okay, so that's to the right. That's to the right of the y-axis. Sorry, not below. We said to the right and above. So we need to identify the part of the graph that's to the right and above. Okay, keep that in mind. So to the right and above. So this entire portion is to the right, but not all of it is above. If we want to the right and above, so this is to the right. Above, we have to stop at 5 because if we go further, we're going to go below and then we're going to have to the right and below, which is not what we want. We want to the right and above. So this portion, okay, it's basically quadrant 1 that you'll always look for. If they say to the right and above, you're looking for it in quadrant 1. But yeah, nevertheless, between 0 and, okay, I'm giving the answer, I shouldn't give the answer. But as you can see here, okay, this is the part of the graph that's to the right of the y-axis and above the x-axis, right? So now let us give this answer in terms of x values. So I'm going to say x is an element of, what's my most left x value here? Someone tell me, please. What is my most left x value? Yeah, you guys sure it's not 5? Okay, so 0 is indeed correct. It's not 5. 5 is a y value, remember? So x is an element of, I included, I'm going to exclude in my question because why not? I excluded in my question, so now I will exclude in the answer. What about to the right? What is the, yeah, I think you guys get the point. What is the most right x value basically of this interval? You guys get the point. It is 5. Very good. Done. Okay, so this I've represented the part of the graph that's above the x-axis and to the right of the y-axis, which is basically x times f of x, which is basically x times f of x. So now I've done one of them. Now I can do the second one, negative, when they're both negative. So basically, when one is to the left of the y-axis and at the same time f of x is below the x-axis. Okay, so can someone give me an interval answer straight away, or you can even try and describe it like after first dot line or in between first dot line or before first dot line? Which portion of this graph? Okay, let's not do that. We can do that when we do questions. Here I'm going to show it to you. So again, you can take it step by step. X being negative means to the left of the y-axis, so that's exactly what I'm going to highlight. Everything that's to the left of the y-axis. Thereafter, they say that the left axis to the top below. Okay. Thereafter, we say below the x-axis, basically. So now we have to identify the part that's to the left, done, and then below at the same time. So if we want to identify the part that's to the left and below, we're going to have to skip out the top part and just go with this. This is to the left and below, basically quadrant 3. Okay, you highlight the part of the graph that's in quadrant 3. Okay, so in that case, let us then give an answer. X is an element of, what's my lowest value of this highlighted part of the graph? Negative infinity, excellent, which I don't include ever. And what's my most right value? What's the most right value of this interval? That is indeed -2, which I don't include because the question doesn't include. And those are my final answers for the intervals of this question. Okay, f of x being above g of x being above f of x times g of x times f of x, and so on. Here we have similar variations. They all mean the same thing, right? So remember, this one is positive, positive, negative, negative. What about when it's less than 0? Positive, negative, negative, positive. Okay, 2 options. What about a quotient greater than 0? Positive greater than 0, so positive and a positive, or a negative and a negative. Less than 0, so negative, positive, or positive, negative. Okay, so those are the different variations of essentially the same thing. Okay, so just before we leave, okay, so let's end it there, and then we'll continue, of course, next week. Yeah, we'll still need to do inverse functions, like I said, in trigonometry, so we're going to transfer that. I don't know, you guys give me some feedback, like how do you guys find the pace? Is it too slow, or are you enjoying the fact that it's slow? Or do you think faster would be better? What do you guys think? It's fine. Okay, let's see. Let's see how it goes. But yeah. Okay, thank you guys so much for the feedback. Thank you guys so much for joining the lesson. All the best. Again, I think you guys are on holiday, so enjoy the holiday. We will see you guys again next week, where we'll continue with this and then eventually get to trigonometry. Let's hope we do it this year. But yeah, okay, thank you guys again. I will see you guys next week. Jazakallah khair. Assalamu